Hi, so today I'm going to show you how to get BASIC running on your 6502 system. I'll be using an open source version of BASIC called EhBASIC, and I'll write output drivers for my TMS9918 as well as for a character LCD and a graphics LCD. I'll also write an input handler for my keyboard. So here we have the EhBASIC GitHub page. So I'll just have a look around here, and so we've got the basic assembly file as well as some sample implementations of the I/O subroutines that you need to implement for your machine. So this version of BASIC is designed to run on pretty much any 6502 machine, and you just need to write an input and output subroutine suitable for your hardware. So I'll go into VS Code here and I'll create a new folder for my BASIC project, and I'll start out by creating the files that I'll need. So first we'll need the basic.asm from the repository. I'll create a make file to make building and testing easier, and then I'll create an implementation file for my HBC56. So the first file I'll look at is the basic.asm file, which I should be able to just copy straight from GitHub. Given there's only a couple of files, I'll just copy it this way rather than checking it out, and I'll paste it in here. And then I'll do the same with one of the sample implementations. So I'll just pick one at random, the RSI mon, that'll be fine. So I'll copy that and paste that into my project. And then I'll fill out the make file. I'll just copy one of my existing ones from one of my test projects. And I'll just update the include paths and the default assembly name. I'll also change the default display that the emulator is displayed in to go to the window that I'm recording here. So the first thing I need to do is make this code assemblable with ACME assembler, which I've been using for the rest of my 6502 code. So I need to update the pseudo opcodes from period to exclamation mark, and need to update the origin to use the asterisk syntax. So moving on to the implementation file, the first thing I'll do is add my kernel include file, so that will add a lot of support functions which I need for my system. So then I'll first write the initialization code. I need to add keyboard support. I need to put the TMS9918 into text mode, clear the screen, and then turn the screen on and enable interrupts to give me a flashing cursor. Now the code to copy the various I/O vectors I can keep from the example. Then I can remove all the platform-specific unused code from the sample file. So the next thing I'll need to do is write my output driver for the TMS9918. So this subroutine takes an ASCII character in the accumulator, and it's intended to output that to your display, whatever your display is. So I have a lot of support functions already for my TMS9918, which I can then use or reuse to implement this output subroutine. Now EhBASIC uses most of the 0 page, so you need to be really careful which addresses you can use there. So I'll just grab a few to save and load the registers, as it's more efficient than pushing and pulling. Create some definitions for a few of the special characters that I'll need to handle in this routine, which is just return and backspace. So I can make use of my console library, which I've already written for my TMS. This provides a console-like environment which keeps track of the cursor position and provides an automatic flashing cursor, which is driven by the TMS9918 VSync interrupts. It'll also do other nice things for me, like automatically wrapping to the next line, and when it wraps after the last line, it will scroll the whole display up, and will do all of this without any user code, which is pretty convenient. I have similar code for the LCD displays as well, but I'll get to that later on in the video. Actually, I'll just quickly show the console test program, which is in the repository as well. And this just shows you the type of functionality that's automatically provided by the console library. So here you can see we've got a flashing cursor, enter is supported. It keeps track of the cursor location, so you can move that around the screen, and it will also automatically scroll the screen for you. Okay, so back to the basic implementation. So now I need to check for the special characters, which I'm just supporting the new line and backspace, and just manipulate the console accordingly. So I could make these generic functions which are reusable, but at this point I haven't done that. Now we also need to make sure that we restore the X, Y, and A registers before exiting the output subroutine. I'm disabling the interrupts so the automatic flashing cursor doesn't get in the way and stomp our VRAM locations. Backspace is a bit trickier, and again I should make this part of my console library so it can be reused. So the last thing we need to do for the output driver is output normal ASCII characters, and so this one's fairly straightforward. We just set the position and push the character out. So that's output done. Now we'll move on to input. So this one is really easy because it just happens to have the same input and output requirements as my standard keyboard function. That is, it places any red character ASCII code in the accumulator, and it sets carry if there is a character. So I'm not going to implement load and save, so we'll just set them RTS. Next I'll remove the interrupt code because I'm not worried about that either. And we'll set up the various I/O vectors which tell EhBASIC where to find the I/O routines. Alright, now let's try to assemble it. Okay, missing file. Let's see. So it's the kernel that it can't find. Could be an include directory into the ACME command. Let's have a look. Ah yeah, so I forgot to update that path. Okay, try again. So we're further, we've got a syntax error. Let's just have a look. Where is that? Ah, I forgot to update that for the ACME syntax. Okay, let's try again. Well, it assembles, that's a good start. Let's see what we get. Memory size, whatever. Looks promising. I'll just try a few quick commands and see how it's... Yep, so integers and strings, looks good. Bit of addition. Awesome. Okay, so I think I'll remove that memory size question because I don't care about that. I'll just make it the maximum size we support. And I'll see if I can update that welcome message just for fun. Okay, so digging through the basic assembly code, and there's the memory size. So yeah, so I'll just skip that. And we'll jump straight down to the next section. Let's try that. Okay, so I need to limit it. I think it's stomping my I/O space in the top of memory. So yeah, there it is. So I'll just limit it at 7000 hex and try again. That's better. Okay, so I have to try the obligatory looping print program. Awesome. Okay, so the welcome message, that should be easy to find, and I'll just add for Troy's HBC 56. Okay, let's try that. There we go. Alright, let's try a program with some input. So I'll do a quick guess the number program. So I'll generate a number between 1 and 100, and I'll just loop until the player guesses what the number is. And of course we'll have to give them some hint along the way. Okay, let's run it. Actually I should have guessed this like a binary search if I was smart. Winner! Okay, so that's the TMS. Now I think I'll try and write an output driver for my character LCD as well. So I'll just duplicate the existing implementation file and I'll modify the output function for my LCD. So I'll also need to modify the startup code because we don't care about the TMS, so we'll need to initialize the LCD instead. So similar to the TMS, I have a library of functions to use to work with the LCD screen, which is all on GitHub, and it makes it a lot easier to work with. So I'll turn the display on, have a blinking cursor as well, and the only other subroutine I need to modify is the screen out. So I won't worry about backspace for now, we'll just do carriage return. So for visible characters it's very easy, we'll just send the character to my LCD library which will take care of it. So like the TMS library, I also have support for tracking the cursor position and going to the next line, and also scrolling the entire display vertically when it reaches the end. So I just need to put in some parameters to tell my LCD library which model of LCD I'm using, and give it a buffer address which it uses for scrolling the display. So I'll just update the makefile to build this version instead, and let's try it out. Okay, it runs, but obviously I've got no LCD in my emulator yet. So let's burn it to a ROM and we'll try it on the real deal. So I haven't used my LCD card in quite a while, so I'll just make some room for it and plug him in the front there. Cross my fingers and see how it goes. Okay, well that's a win. It only has 4 lines of display though, which is a little bit limiting for something like BASIC. But I've got an idea for that, given that I'm using a graphics LCD, so let's try that next. So this is next day. I've done some refactoring on the BASIC code, and all I need to do here is add a new output subroutine for the graphics LCD. Okay, so I've also written a tile map library for my graphics LCD, which should make this quite easy, and I'll use an 8x8 pixel tile set, which will result in a 16x8 character display. So I've brushed over the code a little bit here, but it's all on GitHub. So let's try that out. So instead of modifying the makefile, I can make a specific target, and I'll just do that. Now I'll burn it to a ROM and we'll try it on the machine. Okay, so that looks a little bit better. 8 lines I guess is better than 4, but still quite limiting. Okay, so I think that's it for this video. I hope you enjoyed it, and I hope it gives you some insight into how to add BASIC to your 6502 build. Please consider subscribing, and I will be releasing some videos on programming this machine from the ground up that you can follow along with on the emulator. So stay tuned for that. Thanks.